this panel debate then is in collaboration with NORA. So my name is Klas Pettersen. I'm the CEO of NORA, and NORA, for those of you who don't know NORA is a Norwegian collaboration among universities, university colleges, and research institutes within AI then. And UiT, the Arctic University of Norway, is one of the collaborators. So today we have a great panel. You know most of them or you know all of them. They have been keynote speakers, and Mikael has been very active throughout the conference. So let me present Sir Bologna, Professor of Computer Science at University of Copenhagen. Sofia Ananyado, a Professor in Computer Science at University of Manchester. Marina Marie-Claire Høne. She's the leader of the UMI Lab at the Technical University of Berlin, and also Associate Professor at UiT, the Arctic University of Norway. And Mikael Kampfmeyer, you are an Associate Professor, I believe, at the University of Tromsø. So the topic of the panel debate will be the future of AI. But before we go into these real questions, maybe you should also be allowed to present yourself a little bit more in detail. Serge, if we start with you, could you say a little bit about your research career, maybe, and maybe also a little bit about the Danish Pioneer Center? And you have already said a little bit about why you ended up there.
Sure. Yeah, so I'm assuming people got the introduction from Lena before, so I'll just say I moved from Cornell to Copenhagen, University of Copenhagen in June. I've only taken one semester of Danish so far, so I can't speak in a Scandinavian language at a meeting yet. So I moved to become the head of the Pioneer Center, as Klas mentioned, and it is a 10 to 13 year project funded by 5 different foundations in Denmark. It involves 5 universities, both in Jutland and the capital region. And it has a set of about 18 co-leads, and they're distributed across 7 sub-areas of AI and 10 areas of societal impact. We were meant to launch, if it weren't for Corona, we would be launching in about a week. But because it keeps getting delayed, we decided to soft launch. So we're already putting up posts for PhD applications, postdocs, visitors, and so forth. And I think you can gather from what I presented in the keynote that one thing we want to emphasize in the Pioneer Center is transparency and fairness and AI techniques that connect the socio-technical landscape, connecting people and technology using responsible AI methods.
Excellent. We will discuss those topics in more details. Please, Sofia, could you say a couple of more words about yourself, please?
Sure. Yeah, my name is Sofia Ananyado. So I've worked at the University of Manchester for many years now. So I'm a computational linguist by training, and work now in computer science, natural language processing. I'm also responsible for the National Center for Text Mining in the UK for the past 16 years. So my work is natural language processing, but also very much translated to specific applications such as biomedicine. Hence the focus also of my talk yesterday. Although the models we're developing that can be applicable, initially lots of things we did was with the preoccupation was the translational aspects. So the areas of my work have been from information extraction, summarization, terminology, developing resources and systems. And my whole team in Manchester is really related with this type of research. So that's all about me.
Thank you. Marina, please.
Yes, thank you so much also for having me here today. So my main topic now also as leading UMI Lab, so it's an independent research group, is explainable AI. And I started with this topic long ago, like 2010, when I was starting during my master's as a research assistant at the lab of Klaus Robert Müller. Yes, and then for 2 years after my master's, I went to a company called Otto Bock. And there, my focus shifted a bit to domain adaptation, because Otto Bock is developing prosthetic devices. So when you lost your arm, so when you are an amputee, then you need a prosthetic device, and this can be controlled with small electrons around the arm. And there, I developed a stable algorithm for controlling those devices. But when I, after 2 years, come back to University of Berlin, so to TU Berlin, I get back to explainable AI and did my PhD also focusing on this topic. And yes, then I think this is a bit funny because, defending my PhD, I was in the 9 months pregnant. So, and this was a really brilliant time. Because having then my PhD, I could go for 1 year in maternal leave, being relaxed and no stress on my head with the PhD anymore with the defense. And when I came back, I was on a teaching position, teaching machine learning and seminars and so on. And then I got wrote a proposal and got a funding from the German Ministry for Education and Research for my project, for my own research group, which is great.
Excellent. Mikael.
Yes, so hello everyone, nice to be part of this panel. So I did my PhD here at UIT. It's now a few years ago, I guess, finishing in 2018. And during that, I was working mainly on computer vision problems, deep learning, but initially focusing out on the domain of remote sensing, so images from airplanes, but then transitioning a little bit more into the medical field, so working on computer vision for medical imaging. And they are often focusing, or mainly focusing, on kind of learning from limited labels, so things like clustering, self-supervised learning, unsupervised learning, semi-supervised domain adaptation, and those kind of things. So everything which kind of involves not having kind of this perfect situation which you have in the supervised learning setting. And then after spending some time at CMU with Eric Singh in the machine learning department there, and also some time in Klas Robert Müller's group at TU Berlin, I came back here to Tromsø, and I'm now in an associate professor position, continuing working on these problems around learning from limited label data.
Excellent. So now we know you quite well in the panel. So let's start the future of AI. Let's start with natural language processing. Then many of you have been working within that. So Sophia, you have worked within NLP for quite some years. What do you see as the future of language models? I mean, many of them are getting larger and larger and so on. Is that what kind of the future brings, or is it? Let's hear.
That's a challenging and a very interesting question. So obviously, the large scale pre-trained language models such as BERT or GPT have been extremely important in in AI in general, and in natural language processing. So they capture knowledge from labeled and labeled text. And we're talking obviously here, not in millions, but now billions of parameters, which then can handle, especially in language, challenges that we have, such as disambiguation or lexical or syntactic structures, which are widely used in several important in NLP tasks. So we use those models because we don't want to learn models from scratch, but we use those pre-trained language models and fine-tune them to specific tasks. As we all know, natural language processing is very challenging because we have several downstream tasks and applications. And typically we have divided different types of problems. You have the natural language understanding, which is more syntactic analysis, classification, etc., and then the natural language generation. And typically we have divided those big, large models that GPT is better for generation and BERT focuses more on understanding, although currently we have models that they can jointly train language models, joining them together. So we heard a lot about pre-training is nothing new, clearly, because it's part of transfer learning, and we can capture, knowledge from different sources and apply it to the knowledge to target stuff. So what are the issues now? The first, I think, there are several. One part is efficient pre-training. So how can we pre-train language models at a lower cost? And that's an issue. People, of course, are working a lot on that. Some people worked on model compression. So can we compress big models to smaller ones? An example of that is Albert. So we can share perhaps parameters by using different techniques. Apologies. And very useful and very well known in our field is, again, is Distelbert, which is quite fast, is cheaper, and light transformer models are quite useful. And the different other efficient, training techniques like distributed training. So other things that we have to look at is about the knowledge that we capture in the pre-trained language models. And this knowledge is both linguistic, but extra or pragmatic or word knowledge, common sense knowledge as well. So for the linguistic knowledge, there have been several, again, ongoing research about what kind of techniques we use to capture this linguistic knowledge. Perhaps the most well-known is the knowledge, the representation probing. Then we can capture different syntactic, semantic, or local or different long-range types of analysis. But some of the questions that I think still are not clear is to what extent the model's performance can be attributed to the architecture or other than the knowledge per se, which is pre-trained. And I'll discuss a bit more about, I don't know if you want me to stop and come back, or because there's other thoughts. I can either stop now or I can continue about this.
Let's see if anyone else has some thoughts, and then come back to you, Sophia. In the panel, by the way, you don't have to raise your hand. Please just, if you have any thoughts on this, please speak up. If not, Sophia, you could continue.
Okay, so the other types of information of work is about, again, the type of knowledge we embed, we use to enhance those models, pre-trained models. And we have all this other, besides using basically textual resources, label and label, we have external source knowledge bases, knowledge graphs. We have annotations, we have other domain-specific data. And this data, they can be used as priors. So we can combine knowledge with pre-trained models. So increasingly, we're looking at the impact of how domain knowledge can enrich pre-trained language models for different tasks. And the reason I'm talking a lot about domain knowledge is because I'm working a lot in the area of biomedicine. So obviously this is something that preoccupied us a lot, because if you're using the general models, how useful are they in different downstream tasks that are more domain specific. So the problem there we have is that although those models are very big, the number of labeled, actually, of domain-specific data that we have is limited, and that's one of the issues. So in this case, we want to think a lot about domain adaptation, which is very important for domain-specific applications, and with that, it's very important for improved performance. So here is actually, and I'm saying that because I read just few days ago. Actually, the paper came out end December from a team in Microsoft, talking about fine-tuning of large pre-trained language models for domain applications, and the domain was biomedicine. And they mentioned something that I thought was very interesting. So the way we are fine-tuning currently those big models for a specific task, it's very challenging, especially for when you have small data sets, small label data sets. This kind of fine-tuning, and that's a challenge, can be very inefficient in terms of computation and also not very effective. So one of the questions is actually, how can we bridge the gap between the pre-training and the task-specific fine-tuning in several of these applications? One of the things that they were mentioning, and I thought was quite interesting, was, and perhaps definitely an issue of discussion, is how much the fine-tuning performance is sensitive to the pre-trained settings, and how it can cause fine-tuning instability. And so the different techniques perhaps one has to examine, or adaptation techniques to avoid fine-tuning instability. More about this, and people, of course, have used adapters as well as a more lightweight fine-tuning strategy compared to, fine-tuning a whole language model. So there are many various techniques. So that the things which I think the future is people who are examining more and more. Also is important to, when we're talking about general knowledge and how we can have a better understanding by making the language models more knowledgeable. It's quite important. So either how we can inject knowledge, how we do knowledge augmentation, and for instance, from external knowledge sources like medicine, UMLS, and how we can use external knowledge graphs, for instance, which is an important part of pre-training. So I think these are aspects by how we can learn from large-scale corpora, and the different knowledge base is an important part. And perhaps
Can I ask a question in between, because I think it fits a bit because of the knowledge. So I always coming mostly from the direction of explainability, trying to understand now also this big, deep NLP algorithm. And there I have a question which popped up recently. So I mean, for images, we have global explanations by activation maximization. I don't know, I guess you know the images which are looking a bit like, I like to call it magic mushrooms images, where you can optimize over the image and get the image that maximizes the output, for instance, of a class boat or a dog. So, and I ask myself if this is also possible for text, like in order maybe also to figure out if there are neurons with some racial contents or some other violent content. So is this possible to do this for an NLP task, also to do this maximization, that a sentence come out or a whole text, like what is activating this neuron the most?
Yeah, I think for your question is what kind of segments in the text, what kind of spans we want to actually focus on, we provide more attention. And initially, if I understand your question, because I don't know anything about images, but initially we were looking more at tokens, and then more at spans and more phrases. So I think how we're actually focusing on specific types of knowledge, if as the tasks are different, we are looking more of infusing knowledge and adapting knowledge based on different types of text segments. Another part which I think is very important here are the limitations of BERT type models, especially if we want to capture longer information, which is very important in several tasks. So I'll give you an example from electronic health records. Okay, it's so electronic health records, people think are quite small, and you have small snippets of information. But if you want to look at longitudinal data, which are specifically, you have the history of a patient, the current models are not adequate because they have the limitation of how many tokens you can have. So I think for NLP, it's quite important, specifically for the bear type models, to be able to capture longer type of information. And I know people are working on long transformers and all that, but I think still is what we capture, because you capture a token, you capture span, you can want to capture whole information in a document to be able to gather information. And I think there are limitations currently. I think one is that how much we can capture using the existing models.
Just one question, maybe this will be back to Marina then, but because we are touching now upon explainability as well, and in images, but maybe also then in text. Understanding is one thing, but understanding the code is one thing, and understanding the phenomenon may be another thing. And in images, you showed very nicely, Marina, examples of what could mostly activate neurons and which pixels, for example, are kind of important to make a decision. I think also comparing with the brain, when we do choices, when I decide to buy a shirt, for example, I do the choice first. I'm not aware of kind of why, maybe, and the same if I see the image and I categorize this image, I just can see it, and then afterwards I do some kind of post-purchase rationalization. It's a choice supportive bias is the proper word, I guess. But this is kind of different. You have kind of investigated, of course, the algorithms, Marina, but it's also about if I need an explanation, for example, if I have a service from the welfare system or a hospital or so on, if an AI algorithm makes decision, it has to be explained. In language processing, do we have to have the explanation from the same algorithm, or could we have another algorithm explaining the choice of the first algorithm? Because this is pretty much how the brain does it, I think. This was maybe a hard one, Marina. You're muted, Marina, so you have to unmute.
Okay. But are you focusing on NLP or just in general, like having?
Maybe in general. Yeah, I mean, your experience mostly from image processing, so I guess both. But okay. But NLP also maybe, because maybe this is different in NLP and when you're taking decision based on language and so on.
Yeah, so maybe for NLP, Sophia can afterwards say something to this. So I got a similar question after my keynote. So I guess the question is like, can we have a system that is explaining, or no, can you repeat? So can we have a system that is explaining another system, right?
Exactly, yeah.
Okay, yes, and I think of course, this would be great. Also, if then the system can explain the other system with words, right? So for instance, we are classifying animals or so, and then the other AI system is telling, okay, there is an elephant because I see this and this, or there's a horse because of this and this horse features. But the thing is, like, we are shifting the problem, because now how can we know that the other explainability, so the other AI system, which is explaining the AI system in the first place, is working correctly? And like, this is the issue we have with explainable AI. I mean, the algorithms are getting more and more complex, right? So are getting more and more opaque. We all know this plot where explainability is, or model complexity is plotted on the y-axis against the model accuracy. So models are getting better and better, but also more opaque. And this is, of course, for safety critical applications important that we understand the model. We don't only get a great accuracy, but we also need an explanation. So why is it working? Because maybe you have seen my keynote there, I focused a lot on the artifacts which can be in the data, like for instance, clever Hanses or backdoors. And especially in safety critical areas there, for instance, it's just important that the system is working correctly. But when it comes to explanations, then we just don't have a ground truth explanation. And this is the biggest issue in explainability. And this is why we don't have any state-of-the-art explainability method so far, because we just cannot measure how good is the explanation. I mean, there are some definitions how we can measure it, but every measure so far has its limitations. And it's always like that we humans gave what we want to see. For instance, when we just super simple, like we are classifying MNIST digits, okay? And then we have like the shape of the digit and like the segmentation of the digit, and we applying our explainability method. And we could say like, okay, if like the digit is contributing to the prediction of the digit, then it's a good choice, okay? But for instance, just take the case where you classify only between 3 and 8, right? And so for the 3, there are just missing like 2 blobs, because when you make an 8 out of the 3, you have this additional areas where something is written. And so this procedure of just looking if the explanation fits the segmentation of the digit is not working anymore. So like, because the model found some new features, which we maybe didn't thought about in the first place. And this could be also in all the other areas and all other data sets. So what I want to say is that if we have now an explainability model explaining like any model, then we cannot really measure how good is this. And this is, in my view, the biggest challenge we have in AI, how to quantitatively evaluate our explanations.
Mm. It's the same. Serge, maybe if you could comment. I mean, you do kind of research on narratives now. Is pretty much the same, and also mention like things like sarcasm and humor and so on. It's hard to understand for algorithms. How are you planning to treat that in your research projects? Understanding memes that might be also full of sarcasm and humor.
Yeah. I mean, to be honest, in the early stages, the students I have working on it, I am simply having them hard code the presence of sarcasm. It's such a hard problem. At this stage, when we're going to Twitter and Facebook and collecting source material for the comments and narrative extraction, it's like that one slide with the related work. There's like 24 sub areas of AI that need to be solved to tackle this problem. So we're giving ourselves the luxury of holding some of those research areas constant and just saying, I'm going to give you the answers on that, shine the spotlight on the unfalsifiable narrative components, figure out what the off-the-shelf BERT-based representations give you in terms of possible similarity between statements with respect to narrative, figure out how hard the problem is and tackle that. So as a computer vision person, I don't have a silver bullet for nuance, context, sarcasm, irony.
Could I just ask you a question? When you gave your talk, it's understandable that you kind of went into birds when you wanted to look at biodiversity, but why did you end up on hand drying? Why was this your first choice in narratives?
Yeah, no, I acknowledge it sounds a little silly, but in fact, there are some other, if you look in fairness and ethics discussions in AI, it's common to distill problems to something that's truly pedestrian, just something everyday that doesn't elicit political leanings and so on. And you may have heard the thought problems involving soap dispensing, which has to do with fairness with respect to skin color. And it's the kind of thing, the crowd always chuckles when people bring up soap dispensing. It has some kind of sensor that looks at the presence of a hand, and it's supposed to dispense an amount of soap. It turns out that doesn't work the same for everyone. So it's kind of, it appears to be an anodyne problem. And then guess what? It actually touches on a huge amount of issues in AI. There's also surprising philosophical discussion on how the toilet roll is put on the toilet roll holder. Should the paper go out or in? And these are rhetorical exercises. So you can have creative writing classes, philosophy classes. They take these little problems that are just sitting there and they look like toys. And it turns out that people have really strong opinions. And then you can use that. Like the humor is part of it. It's meant to be something like when I said there's an obvious choice, with the, which hand drying method you would use. You notice I didn't say what it was. And the point is, I want people to think about that and say, wow, every time I wash my hands, I have an opinion and it's based on some narrative. Is it based on science? I don't know. So my point is, it's meant to be a little bit funny, but it was chosen in the same way that we chose birds after a long period of examining many different narrative sources. And eventually we hope it will become the Cub 200 of this project.
Excellent. I will go on to you, Michael, soon with and you can think a little bit about the question I will give you. It's about deep learning, and it has models are larger and larger and larger, and I have had a lot of discussions in the field if this is kind of the way to go in the future, like these discussions between Benjo and Gary Marcus and so on. So if you can think a little bit of about that, while I have the last question for Marina when it comes to explainability. I was thinking, or we have been talking about explainability and understanding, but is there a trade-off? This is often kind of said in the field. Is there a trade-off of algorithmic explainability and versus accuracy? Is this a huge problem in the field, Marina?
Explainability versus accuracy. Yeah, this is like the plot I tried to describe in the first place. Like I think so. For sure, yes, right? Like linear regression is much easier understandable by humans, like as deep neural networks, for instance. Sure, there is this trade-off, and it's of course a challenge because especially when it comes to medical diagnosis or even surgery by robotics, we want to have an accurate robot who is making the surgery with us, right? Yeah, so there's also this field I'm working on together with Michael and some other colleagues from Norway, which is great, where yeah, we're working on self-explaining models. So there's this claim from Cynthia Rodin, so professor of computer science from the Duke University, and she claims that we should stop explaining black boxes, yeah, because like we don't understand them in the first place, and we should start developing self-explaining neural networks. And but of course there is again this challenge that they are mostly not that accurate as black boxes. So there is a challenge, and I think it is good that people are developing also models that are understandable in themselves. But as I showed also during the keynote, a project we are working on at the moment, Michael, me, and also Robert and Shruti. And yeah, it's that they don't have this explainability capacity in themselves. Like you want to have a self-explainable model, and then we just figure out, okay, it's not enough to detect, for instance, artifacts like clever Hanses. And this led us that we put this model-aware explanation methods on top of the self-explaining model in order to get more accurate explanations.
Excellent. And then because I have been sending out by email some topics of the discussion, but I guess Michael has not received that email, so that's why I wanted to prepare a little bit about the next question. But do you have some comments maybe to this topic, yeah, Michael, or the one I tried to ask you? I mean, deep learning, how far can you get with deep learning? Do you need some hybrid models? Do you need to have some knowledge baked into the models? Is that the future?
Yeah, let me first just briefly go back to Marina's comment, because I guess there also one point is this kind of trade-off between accuracy and explainability, right? Because when you have these self-explaining models, often you kind of constrain the model a little bit in order to make it explainable. And then, of course, you can end up with performance drops. And then there's a question, okay, how much do you value the explainability versus the performance drops? And there's a question, how to find a nice balance there, and it would be problem dependent as well. But then there's also, since Marina touched onto these kind of artifacts and things like this, are there ways that we can try to make, like after we've trained the model, we can identify these artifacts, can we go the next step and try to remove these artifacts from the model? So can we make the model robust towards these artifacts? And I guess there's research going on, but it's not a solved problem. So there's a lot of things to explore there. But you had another question. I'm not sure if Marina wants.
No, excellent. So yeah, robustness is also, of course, a challenge. But we are talking about the future of AI, and again, back to the larger and larger models, energy consumptions, and so on. Is the future larger and larger models? Yeah, that was the question.
Well, yeah. Well, I guess I don't think it is. Also, once you get to these larger and larger models, it's becoming more and more difficult for people in academia to work on it, right? So when you look at these big models, which are now mainly trained by industry, we as people in academia, we can't really compete with training these huge models. But I don't necessarily think it's the way to go, because in the end, we have so much knowledge which goes kind of beyond just training models, only looking at what the data contains, trying to restrict these models in order to make the learning more efficient. And then you would expect that even smaller models can actually utilize this knowledge and get similar performance, even with small models.
You're actually touching upon a very interesting point, industry and industry versus academia. So what do you think, could academia compete, or should academia compete with industry? How could we collaborate? Maybe could maybe be a question. Michael.
Yeah, I guess collaboration is probably the way to go. I don't think academia can compete when we're talking about training these huge models, because we have limited resources. We can't just throw hundreds of GPUs at a problem, and I guess it's also not really the job, I guess, of academia. I guess we're trying to kind of find new ideas, trying to find new solutions to existing problems, trying to make things more efficient, maybe. And then, of course, down the line, it would be nice if people can try these things on huge scales and things like that. And then that's probably something which is a little bit out of the scope for most of us, at least in academia. But there's definitely an importance there as well of trying these things at big scales. And then that's where the industry comes in.
Sophia. Sophia, you have a hand?
I just wanted to mention, it's a very good question about how academia cannot compete, of course, with industry. But there are lots of interesting research coming out of academia for how to create greener models, which from comparison to this large-scale, models that we have. So how to, for instance, reduce the parameters and how to actually produce models which are perform equally to models like GPT-3. And I've seen several types of work like that, which are very interesting because it's not feasible for academia to work in this huge, billions of parameters. So there are various ways, for instance, clever ways to convert, for instance, different, recent work I've seen how they can convert textual inputs into more, close questions. So there are various ways, basically, that's an example of reducing the parameters and having performance which is equal to large-scale models. This is a kind of interesting research of the future of our field. And also, talking about greener, it's actually you have a large carbon footprint of these models that we have to think and address. And also I wanted to say something about explainability before, since I'm talking. And something we have done, because obviously for me, at least, explainability is what we had before in the previous talk, is the human in the loop. So the explainability comes from humans, because we created systems that in the end, they've been evaluated by the humans and they were putting their input there. So we are basically training our neural nets from input from humans. And I think explainability will come a lot from existing, of course, prior knowledge bases that we have, but also, at least in text, but also for humans, humans in the loop.
Absolutely. In the industry, many of you have experience from industry and have been working closely with the industry. How is that experience? And maybe Serge would be the right one. Are there kind of differences between the US and Europe when it comes to how to collaborate with industry?
Yeah, I think in the US, based on my experience, almost 20 years, I witnessed a massive transition from government and defense-based funding to big tech company funding. So a lot of research groups are supported by large research grants from Google, Facebook, Amazon, Twitter, and so on. And not only that, the professors themselves have dual employment. So they may actually run two entire labs, one within DeepMind and one within a university. So that's very common, to the point that professors who don't do that in the US feel like suckers, or that they're missing out. I think another thing that's tied to that is that students do these kinds of creeping internships. So they'll do a summer internship and they get kind of drunk on the power of sort of unlimited GPU resources. And then with the excuse being that they need to submit to a conference, the company offers, say, a 20% extension of the internship into the academic year. So then the student is kind of doing a miniature version of what the professors do. And who knows if it's 20%, it's probably 100 plus 100. And then they still have remote access to all those compute resources. And you can just imagine all the deans and provosts just wringing their hands over this. Like, what does this mean? How in the world is this compatible with their dissertation goals? Is it unfairly influenced by industry? I mean, I'm only offering observations and not answers here.
But if you should try and answer, Serge, or not an answer, but what, I mean, it's a bit different, I understand, in the US and Europe, but what's a good part about the US system? What should we adapt in Europe, or what could we be better at?
Wow, that's heavy. I think, wow.
Anyone else?
Yeah, maybe someone else can take that. It's very raw for me, so I don't have a pat answer.
No. But by the way, Serge, you had a talk at the Nordic AI Meet in Norway also, and there you also talked a little bit about AR or virtual reality.
Yeah.
So you're doing research on that, and Facebook or Meta and other large companies, they're putting a lot of effort into building a virtual world. Yeah. So how do you see the field of VR and AR evolving? And this is again with companies driving kind of this field.
There's a part of it that's quite related to what Sophia and Marina are talking about, which is the role of embodiment when it comes to learning. Embodied learning, when you think about large language models, it's possible to create them in absence of embodiment if you want to, but the growing interest in physically realistic virtual environments will perhaps make it much simpler to create embodied learning environments. So you can see through interacting with objects. You push a ball off a table, it falls down, and so on. So I think I wouldn't say that's one of the reasons that Facebook or Meta are investing so much, but I think I find it exciting that these increasingly photorealistic and physically inspired virtual worlds will allow embodied learning to happen. The impact that has on these very large, high capacity models is that I think we are at the cusp of a transition from so-called data set AI to embodied AI. So data set AI, which I've very much been immersed in it, is just this time-honored tradition of collecting gigantic data sets, getting them as labeled as well as possible, training models, and hammering it from every direction to solve every possible corner case. And that is an arms race that results in some very large, like Sophia was talking about, these billions of weights and so on. However, if you put things into an embodied context and you think of the analogy of a little mosquito flying around, mosquito brains don't have that kind of capacity, but they're able to move and they can gather baseline, they can get parallax by flying around something. So I think the switch from data set AI to embodied AI will allow these dramatically shallower approximations, thin approximations, and so on, simply because you're able to move. And if you think about the absolute hardest MNIST digit, our field is pretty invested in solving what that digit is, or the weirdest ImageNet picture of a dog. We have to solve that. But in an embodied context, you could also just wait 200 milliseconds, try again, and use, a model that was state of the art 7 years ago, and it'll be just fine. So I think that is going to be a tough transition, because students really like downloading those big data sets onto the box under their desk and just hammering away at it. And if we change so that it's now about habitats, virtual environments, simulation environments, instead of publishing these gigantic data sets, that it's actually an environment, well, that's a generational shift. It's almost like people who used to store MP3s on a big hard disk, and you tell them, we don't do that anymore, it's all streaming. And they'll say, well, you can pry this hard disk out of my cold, dead hands. Like, I just need the data on my hard disk. When that transition happens and there's just environments, classrooms, shopping, supermarkets, whatever these environments are, it simply won't be possible even to do a snapshot, because it won't fit in memory. So I think we will see students switching that mindset, and the old timers will say, oh yeah, we used to download all of Ego 4D onto the lab hard disks and try to beat the benchmarks. That is going to change, and I think that it will give us permission to use simpler models and focus on other issues like embodiment.
I guess this is also how the brain works. You kind of create a light version of the reality, and try to update that all the time. And also, if you see at Tesla and the new kind of autonomous vehicle algorithms, that also kind of have an intermediate step where they create a mental model where the AI kind of is applied on the mental model, more or less a simplified model then. So opens a lot of doors. We don't have. We could have discussed this a lot longer, I guess, but we are approaching an end. So, but maybe if any of you have, or maybe all of you, we should go through a final comment. Do you have a final comment about the future of AI? And if there are any students here, what would you be your advice to a student? Let's start with Sophia.
Oh, I thought this up. I think my advice would be to examine for the future is what actually I heard before, that just using and trying to understand about other interesting facets that we can incorporate. That's why I was talking a lot about knowledge, that just having these large models is not a panacea, it's not an end to a mean, but trying to figure out the novelties in how we can work better with, not with such large models, how knowledge can be more efficiently incorporated into those models. And something you before the discussion about something that's very interesting to examine more is how we can actually, to what extent we can figure out how these models are reflecting our human intelligence and how we are understanding our own way of working and our own memory, for instance, our working memory, and maybe chopping the problem into different these facets would be something much more interesting. So yeah, I think we have to think about the human, how these models also mirror human intelligence. Yeah. Perhaps that's my last word.
Excellent answer. Excellent answer. Marina.
Okay, yeah, I mean, there's like a lot, but maybe to focus on just a few things. So first, I think don't only develop explainability method, also focus on like how to quantitative evaluate those explainability methods such that we can maybe somehow come to a point where we say, okay, this is now the state of the art. And also, yeah, just for young researchers, I think it's super hard to cope with all the amount of papers coming every day out. And maybe it's possible to develop an AI system. Maybe it also exists already, some kind of categorizing papers and filtering out like what is new and what is state of the art, just because I think some students are really feel overwhelmed by the amount of papers and don't know where to start. So this is also, I think, a nice field where to work on.
It could be the task of one of the research group here. Maybe. Michael, do you have then a final comment?
I'm muted, of course. So yeah, I agree with both Marina and Sophia, and especially with Sophia about kind of incorporating this knowledge. And I have my background on working with limited labeled data and trying to exploit unlabeled data and ideally limited amounts of unlabeled data. And there you really need to have, need to try to incorporate some form of knowledge, try to restrict these models. And I think there are a lot of domains which are not really explored yet, where there is just a setting where you have kind of limited data, small amounts of data, and usually unlabeled data. So exploring these kind of domains, I think, will be quite important also in the future.
Excellent. And the last word goes to Serge.
Yeah.
Or do you have more, Michael? Yeah.
Well, I was just thinking, since Marina, she came a little bit also with kind of a recommendation to young researchers. I think I would like to stress that kind of mobility is also something that is very important. Just once it's possible again to go visit conferences and visit other research groups, I think it's something that is very important and has helped me a lot, at least.
Excellent. Serge, could they come visiting you in Copenhagen?
Yeah, I would just reiterate my comments about the embodied AI opportunities that exist in the extended reality initiatives. If Facebook and Meta believe so deeply in moving into that area, maybe they'll make some pretty silly toys with it, but as a side effect, we get access to some pretty powerful environments. So let's use that for reinforcement learning and embodied cognition.
I think that was an excellent end of the discussion. So then I will, by that, just close the discussion. I say thank you very much to the panel. I certainly enjoyed, so I hope all of you also enjoyed. Thank you very much.